Welcome back, everyone. Now that we are familiar with the concept of loops in Java, with the concept of iteration in programming languages, in program development, let's actually, now that we know what a external variable is, what a conditional statement is that's going to check for the variable's value against something, another criteria, and what a counter is, what an update statement is. So we have a variable, initial variable, condition against that variable, and an update statement. Let's actually look into the reason why we created this, why we developed this logic inside our main method. This section in this video, we're going to look at additional practices related to incremental development. Now, to do so, we're going to leave this program as is. We're going to create a new program, create a new class inside section 4_1, and we're going to call it multiplication table intro, because we're going to call it intro because we're going to ask you to develop this further on to the best of your liking. Now, let's declare our main method, and let's actually document what this class is going to do. This class is going to print multiplication output of all numbers from 1 to 10. Okay, so it will resemble a multiplication table that is seen on math on 3rd grade. It might be 3rd, 4th, or 2nd, I don't remember, algebra books. So, sample output will be as follows. For example, 1 times 1 is 1, 1 times 2 is 2, 3, 4, 5, 6, 7, 8, 9, 10. Then it will show us multipliers of 2. It's going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, etc., 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 until we get to 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So this is going to be our sample output. Okay, spacing doesn't matter. Most important thing is to see what the output is. To do so, let's do this. We don't know how we're going to start, and we're going to go back to our first video on section 3_4 about incremental development. Now, no one expects you to start writing a code for this output, because it's going to be a challenging task to do even for a seasoned developer. However, we said that break down things into small pieces. Now, what is the smallest piece in this output that we can tackle first? We can tackle printing out this line first, right? Multiplication by 1. We can tackle printing out multiplication by 2. So let's start from there, okay? For example, how would we print out multiplication by 2? We would declare a variable, okay? So let's declare a variable. We're going to say this is going to be my multiplier, right? Is equal to 1, because I'm going to start multiplying from 1. And while multiplier is going to be less than or equal to 10, because I want it to find the 10th multiplication as well, while it is less than or equal to 10, last thing I'm going to do in the statement, let's open up some space. And first thing I'm going to put here is I will not forget a condition, an update that will change my condition to become false one time, right? So I know that I'm going to start from 1, I'm going to go up to 10. So let me increase it, not forget it, so that this does not become an infinite loop. Then now, let me tackle what I'm going to print out. What I'm going to print out here is, actually, let's do this. I'm going to print out int result is equal to my number. For example, I'm trying to print for 2, right? 2 multiplied by whatever the multiplier is. So the first time this program runs, my result is going to be 2 times 1. It's going to be 2. Second time my program runs, my result is going to be 2 times 2. Is going to be 4. So now I'm going to, let me actually reduce the space here so we can fit it in the screen. So now my print out statement is going to do nothing but print out the result and concatenate a space so that I can have a space between my output. Okay, result. Now, let's do this. And let's add here a checkpoint saying that system out print line end of main, right? And let's run this program. Let's see what happens. When we run it, we get 2, 4, 6, 8, 10, 12, 20, and end of main. Since this is a print statement, end of main is concatenated after the space here. So the program works. So I will leave it here for now. Now, there is one thing that I need to be able to do here. I want the next call to actually take this end of main and put it to the bottom, right? Put it to the next line. So before this, I'm going to just create an empty print line. I'm going to call in an empty print statement that will just add a new line, right? So let me run this program one more time. Now I get 2, 4, 6, 8, etc., etc., and end of main goes to the next line. Let me test for it. What if I add a, what if instead of multiplying by 2, I multiply by 3? If I run it, I get the expected result. And if I multiply by 10, when I run it, I get the expected result, right? So in any number I pass here, it will, this loop here will generate an multiplication for that specific number. Now here comes the introduction to the idea in Java called encapsulation. This here is a working method, right? This here is a working block of code. We said we don't want any logical development in main. We just want to control the flow of our program, and we want to just keep our method calls in main. So let's just take this block and put it in some other method so we can call it, right? Let's call this method public static. We're gonna keep our print statements inside this method, so we're not gonna have it return any value, and we're gonna call it multiplication line. So single line. It's not gonna accept anything right now. So I'm just going to copy the whole thing. Actually, I'm going to cut this, paste it here. Now, instead of having that much of a clustered code inside my main method, I'm just going to do this. I'm just going to create my test values. I'm going to do 2, 3, and 10. Actually, always do boundary testing. So my minimum number should be 1. My maximum should be 10. My check, one of the middle checks is going to be 3. So when I call multiplication line, now here comes an issue. I created this method and I encapsulated it. I created this logic. I encapsulated it in my method. But the problem is my method is straightforward. It just works with whatever is inside. So I cannot manipulate this method. I cannot access it from outside. How do I do it? We have seen that in Java, we can create methods that accept values. Okay, let's say this method accepts value, right? Let's call it a number. What am I supposed to do with this number so that this method is going to take my number and print for that specific number this line of multiplication? Do you remember how we changed this value here? And this value got multiplied by the multiplier, and this value's output got printed. So why don't we just take this argument and pass it here? Now in this case, when I call my multiplication line and pass a value 1, and I run this program, I will get the multiplication for 1. I will get the result, a line of multiplication result for the multipliers of 1, right? 1 times 1 is 1. 1 times 2 is, this is coming from this here, right? 2 is 2. 1 times 3 is 3, etc. Let's test it for 10. Run the program. Now we got multipliers of 10. Great, this actually works. And let's test it for 3. Run the program. Perfect, it worked. So in this short video, we saw two concepts of incremental development, two additional concepts. Besides analyzing what is being asked and creating a pseudocode that we did, we saw a third concept, encapsulating, taking this logic and putting inside a capsule, putting inside a method, and wrapping it up with a method block. So from now on, every time I want to see a single line, I don't need to write this line, write like these 8 lines of code again and again. I can just call the method. And I went a step further, and we introduced you to the fourth concept of incremental development called generalization. Previously, this method was working only for a single number that we were to pass here. Now we generalize this method to work with any number that a user is going to pass when it is called as a method, when it is invoked. So we added a parameter, and we said this multiplication result is going to be multiplier that is going to be looped from, iterated from 1 to 10, multiplied by not a number that we declare, but a number that is going to come from the user's invocation of this method. So when we put number here, now we have a generalized logic, generalized small piece of code that we have been able to make it up to here. Now, I will stop this video here. In the next video, we will see how we can take encapsulation and generalization to the next level so that we can print out the whole table similar to this instead of printing out single line. Right now, what we can do is we can do this, multiplication line, and pass a number 1, multiplication line, pass a number 2, right? And 3, etc., etc., etc. This will work. See, we're getting there. However, we said that the reason why we have loops in Java is because of we want to avoid this kind of a labor. We want to avoid human labor that's too expensive to take care of this kind of repetitive tasks. Let the computer do it. So I will see you in the next video. Thank you for your time.